So boys and girls, after you have do the experiment in the virtual lab and obtain the reading, you need to write a complete report about the experiment 4B magnetic field. So as usual, follow the format of the report writings. So under the data tabulations, so make sure you calculate the average value for the angle of deflections and then determine the tangent theta. After that, follow with the plotting graph and also the data analysis to obtain the horizontal component of the Earth magnetic field. So refer to the procedure, we need to plot graph of tangent theta against current. So you need to calculate the centroid, the average value for the current and also the tangent theta. And then don't forget to plot it on the graph. Boys and girls, you are going to plot graph tangent theta against current, so make sure you put the title of the graph and label the axis with the correct symbol and unit. Choose a suitable scale so that your size plotted will be more around 80% of the graph paper. You no need start from 0, is okay. So plot all the points correctly, including the centroid. After that, draw your best fit line passing through the centroid and as many points as possible and try to balance the point within best fit line. After you have plotted the graph, then draw a triangle of gradient whereby your triangle should be large enough, more than 50% of your graph. Read the two coordinates on the triangle draw to calculate the gradient. So determine the gradient of the graph, okay, and then find the value of Earth magnetic field BE from the graph. So for this purpose, you can compare the equation 4.2 in theory. Tangent theta is mu naught n over dBE multiplied current with the straight line equations, because we get a straight line graph y equal to mx plus c. So when we do the comparison, our y-axis is tangent theta, our x-axis is current. So you can see obviously the gradient will represent by mu naught n d over BE. So from the gradient of the graph, the m will be mu naught n over dBE. You might also refer equation 4.3 in the theory. So rearrange, we can able to determine the BE from the gradient of the graph, whereby the BE will be mu naught n over dm. So this one also you can refer to equation 4.4 in theory. After you have determined the horizontal component of Earth magnetic field, you are going to compare the result with the standard value. The standard value is given here. For this simulation purpose, in the virtual lab, the standard value for the BE is 3.5 to the power of -5 Tesla. Okay, so calculate the percentage difference. Then after the data analysis, you can follow with the discussions, and the discussion give your comment whereby you are going to compare the value of Earth magnetic field obtained from the graph with the standard value, whether the BE you obtain is less, equal or greater than the standard value. Then by referring to the percentage difference calculated, state whether your experiment is success or not. Then state the precautions we need to take if the experiment is performed in real laboratory. You might refer to question 12 in pre-lab experiment 4, which we already discussed about the precautions in the pre-lab session. Then state the source of error and give suggestion taken to overcome the errors stated if the experiment is performed in real laboratory. Try to think out. In real laboratory, you are going to read the scale of the compass and also the value of currents on the ammeter. So what kind of error that might occur and how you are going to overcome. Alright, so then the last one will be the conclusions. State briefly the result you obtain with reference to the objective of the experiment. So do a complete lab report about the experiment 4 using the data that you already obtained through the virtual lab, and submit it via Google Classroom. Okay, with that I end the videos. If you have any questions, you might consult teacher through the Telegram or WhatsApp. Thank you class. I shall see you in next video. Bye bye.